Okay, guys, let's go through this little lab that you did. Now, the assumption is that you've already completed this lab, and you're just going back through it for some clarification or just to check your answers to make sure that you're doing them correctly. So I'm going to go rather quickly through this process or through these questions just because you've already seen them. So you don't need all the introduction that would take place normally with something like this. So quickly scanning through this initial problem, it talks about a teacher who wants to order supplies, and it mentions here about the different costs. So for instance, paintbrush is $2 plus $4 shipping, and then you have the canvas panels that he must buy as well. Well, in the end, it says that he's going to buy this for a class with X students. So we don't know how many students there are. There could be 10, there could be 20, there could be 50. So we're going to move ahead with the assumption that X is the number of students and that each student is going to get a paintbrush and each student is going to get a canvas. Makes sense, right? So it says if you, and actually there's a mistake here. It says if X represents the number of panels, that should be the number of students. We clarified that earlier, okay? Write an algebraic expression to find the total cost from the situation above. Well, let's break this up into two parts. Let's break it up into the paintbrushes, which is $2 per brush and $4 for shipping. Now that's a one-time shipping fee. You don't have to pay $4 for every brush to ship. But you do need a brush for every student. And if we have X students, then our expression would be 2 times X, 2 times the cost, or I'm sorry, the cost of a paintbrush times the number of students, plus the initial, or the one-time shipping fee of $4. So that would take care of the paintbrushes. I'll just highlight that to keep everything lined up. So there's your paintbrushes. Then we had canvas panels that are $4 per panel, and assuming again that each student's going to need a panel, that would be $4 times the number of students plus a one-time shipping fee of $1. Total cost, well, total cost means sum, so we're going to add these up. So you can see how these two expressions were broken down. You have the canvas panels and the paintbrushes lined up just like that. The next thing they wanted you to do was model this. And the purpose of modeling is just for you to become familiar with these algebra tiles, which I think will ultimately help you really understand this concept. So 2x plus 4 could be modeled like this. Now you don't have to put them into the rectangle form like I am here, but that would still work. And 4x plus 1 means I'm going to be gathering 4 more x's here and a single blue chip for the shipping. Okay, so we have our 2 x's and our 4 singles. We have our 4 x's and our 1 single. We want to simplify this expression. Underneath there's a space for you to simplify. Well, what we're going to do is we're just going to combine all of the like shapes together, which means I could bring my singles over here, and I could take all of my x's over here, and I would see that when simplified, this expression would be 6 x's and 5 singles. So this expression here would simplify to 6x plus 5. Now, without knowing how many students there are, I can't push this together and call this 11x, let's say. It just doesn't work that way. Okay. Now, you were to have modeled these next 4 examples. So you took your tiles, you arranged them, you counted them up. This is just to verify your answers are correct. Number 1 simplifies. You're going to end up with 4 x's and then 7 single cubes, blue. Number 2, you would have 4x plus 6. Number 3, you would have 6x, because this x right here, this just simply means 1x, plus 9. And the last one is going to simplify to 7x and 3 blue cubes. Okay, so make sure your answers are right there. Now jump on to the next one here. If you have, let me get rid of this writing. I have it all kind of set out aside here, but let's just jump into the explanation. If you break this down on a day-by-day basis, which is what I want to do here. I want to say Monday, I want to say Tuesday, I want to say Wednesday, and Thursday. It tells you that Anna runs X miles on Monday and Tuesday. Now that's assuming that she does, let's do it like this. X on Monday, X on Tuesday. On Wednesday, she goes X plus 3. And on Thursday, she goes twice as far as she did on Wednesday. Well, the way I'm going to write that is like what we did with the distributive property. I'm going to write 2 groups of X plus 3. Okay? So if I'm modeling this down below, I'll tell you what, let me just clear all this out of here. Maybe. So give me a second. I want to try to put together all this with our chips, our tiles. So on Monday, I only have 1 green tile. Tuesday, I have 1 green tile. Wednesday, I have a green tile and 3 singles. And on Thursday, if you think of the distributive property, you're going to end up with 2 green tiles and 6 singles on there. Okay? So if I got some room here, created some room, this would be my Monday. I know this is for investigation too, but I'm just using this spot to do this. There's Tuesday. Wednesday looks like this. X and then 3 singles. And Thursday is 2 groups of X plus 3. So imagine I took this part here and did it twice. Right there. Okay? Monday, Tuesday, Wednesday, Thursday. And you put all of that together, you're going to see that you end up with 5 of these X's, 5 green tiles, 5X. And your singles, 1, 2, 3, 4, 5, 6, 7, 8, 9 of these singles. So your expression ends up being 5X plus 9. All right, moving on down here. Investigation 2, it wanted you to model these tiles. It wanted you to go back through and do this. Just quickly going through how your tiles should look. You would have, get rid of this stuff. You would have 1X and 6 singles. Because that's your X plus 6. And then plus 3X. So I need 3 more of these. Now it says minus 3. And we encountered this when we did our distributive property lab, where you had negatives. Well, minus 3 can simply be referred to as plus a negative 3. So I'm just going to add 3 red tiles to this. Now when we simplify it, we're looking for 0 pair. And 0 pair, or a 0 pair, is just simply a red chip paired up with a blue chip, because the value of that combination is just 0. Positive 1 plus a negative 1 is 0. So this 0 pair right here goes away, as would this 0 pair here and 1 more here. So these things all cancel each other out, and you're left with this expression right here, which is 4x, 4 x's, and a positive 3. Now, at this point, you probably are figuring out a quicker way to do this, and you're not necessarily needing the tiles in order to do all of these, which is fine. That's what I ultimately wanted you to do. But for this next section, it says to model and simplify. Model if you have to, but if you don't, if you've got it, then go ahead and simplify each one of these. I'm just going to share these answers with you so you can check. Number 6 should be 6x plus 4. Number 7 is 5x minus 4. 4x for number 8. 3x minus 1 or 3x plus a negative 1. For 9, number 10 is 10x plus 23. And 11 is 18x minus 12. Okay? The very last one I wanted to talk about here was number 12. It says that one side of a rectangle has a length of x plus 2, and the other side is 3x minus 1. It doesn't matter which side we designate as that. It doesn't really matter at all. It said write an expression for this, the perimeter of this. Well, there are a couple of ways you could do this. You should know that the perimeter simply means the distance around the outside. And you could obtain that by simply just adding all 4 sides. So you could do the x plus 2 plus 3x minus 1 plus another x plus 2 plus another 3x minus 1. And you could go ahead and model that if you'd like, or just push together terms that are similar. Or what we could do here is I could say, well, you know what, I have 2 of these x plus 2 sides, and I have 2 of these 3x minus 1 sides. I could just add those 2 up when it's all said and done. And both of them would accomplish the same thing. Simplified, this expression here, these expressions rather, would end up being 8x plus 2. So the perimeter of this rectangle is 8x plus 2. Okay, that's it for this one. You don't have to worry about 13, 14, 15. It talks mostly about properties, like commutative property, associative property, things like that, which we really haven't spent a whole lot of time on. I feel like we don't necessarily need that for this particular lesson, so that's good for now. All right, hope that helped. Bye.